Good afternoon, students. Welcome back to chemistry class. Today, let us continue the lesson Carbon and its compounds. In the previous class, we have learned what is a heteroatom and what are functional groups. The definitions we learn, and we learn 5 different classes of organic compounds: haloalkanes, alcohols, aldehydes, ketones, and carboxylic acid. Let us revise what are the functional group present in this class of organic compounds. In haloalkane, there are two types, chloroalkane and bromoalkanes. In chloroalkane, the functional group is chlorine. In bromoalkane, it is bromine. What is the functional group of alcohols? It is OH. Aldehydes, it is CHO. C single bond H double bond O. In ketones, the functional group is CO. C double bond O. What is the functional group of carboxylic acid? COOH. That is C double bond O single bond OH. And next we learn what the nomenclature of carbon compounds. That means how to name these carbon compounds. So, to name the carbon compounds which contain this functional group, what are the methods we learn? If it is haloalkane, we have to give the prefix. If it is chloroalkane, give the prefix chloro. Bromoalkane, give the prefix bromo. If it is alcohol, all other groups, alcohol, aldehyde, ketone, carboxylic acid, all these we are giving the suffix. If it is alcohol, the suffix is OL, aldehyde, AL, ketone, ONE, carboxylic acid, oic acid, carboxylic acid, the suffix is oic acid. So these are the topics we learnt in the previous class. Today we are going to learn what is a homologous series and we'll discuss a few textbook questions also. So let us see what is a homologous series. So before learning its definition, let us see a class of organic compounds called alkanes. This you have learnt already. Alkanes, the general formula is CN, H2N plus 2. N is the number of carbon atom. So number of carbon atom is N in alkane, number of hydrogen atom is 2N plus 2. So according to this, we have written the molecular formula of this compound. If it N is 1, C1, H2 into 1 plus 2. 2 into 1 plus 2 is 4, CH4. And how to name them also we have learned. The one carbon atom is meth is the root word. ANE we have to give the suffix. So methane. Similarly, we have written the molecular formula of the different members. If carbon atom number is 2, the molecular formula of alkane is C2H6. Its name is ethane. Next C3H8 propane, C4H10 butane, C5H12 pentane, C6H14 hexane, etc. Now consider this series. What is the difference between the first and second members here? First member molecular formula is CH4. Second member ethane, its molecular formula is C2H6. What is the difference between these two? They differ by one carbon atom. You can see one carbon atom more here. There are two hydrogen atom more here. So they differ by one carbon and two hydrogen atoms. That means one CH2 group. These two members differ by a CH2 group. You can see here also. These two members also differ by a CH2 group. Here also these two propane and butane differ by a CH2 group. So you can see each successive member means adjacent member, differ by a CH2 group. So CH2 group means what will be the difference in mass? You know, carbon's mass is 12 unit and hydrogen mass is 1 unit. So CH2 group means 1 carbon and 2 hydrogens. So 1 carbon mass is 12, 2 hydrogen, 1 hydrogen mass is 1, so 2 hydrogen mass is 2. So 12 plus 2, 14 unit. So these two members, first and second member, differ by a CH2 group or by a mass of 14 units. Second and third member also differs by the CH2 group and a mass of 14 unit. Third and fourth also same thing. So we can say successive members of all the members of this series differ by a CH2 group. Now you can see all these members can be represented by the same general formula. All methane, ethane, propane, butane, all these can be represented by same general formula. For alkane, what is it? CnH2n plus 2. Now all these show the similar chemical properties. If we learn the chemical property means how do they react with other substances. If we learn the chemical properties or reaction with other substance of a particular alkane, it is applicable to all other alkanes also. That means they all show similar chemical properties. Now what about the physical properties? You know, first and second member, the mass is increasing, and second and third member's mass is more than the second, like that the mass is increasing here. So as the mass is increasing, their melting and boiling point also increases. So you know, physical property means melting point, boiling point, all these are physical properties. So they show a regular gradation, regular variation in their physical properties. So what are the properties we learned now here? Successive member differ by a CH2 group. All these can be represented by same general formula. All they are having same chemical properties. There is a regular gradation in the physical properties. Now we'll consider other class of organic compound, alcohol. You know, in alcohol, which is a functional group, OH. You know, alcohol is a derivative of alkane. That means in alkane, one hydrogen is replaced by the functional group OH. For example, here, if we consider methane, CH4 is a formula. So corresponding alcohol, how we can write? In the place of one hydrogen, there will be a OH group. So CH3OH. What will be its name? How to name the alcohol? Corresponding alkane, E is replaced by OL. So name is methanol. CH3OH is the formula, name methanol. Next member of alcohol, how we can write? C2H5OH. Its name is ethanol. Next, C3H7OH, that is propanol, and so on. Now, how we can represent the general formula of alcohol? We know in alkane, one hydrogen is less. In that place, what is occupying? One hydroxyl group or OH group. So, Cn H2n plus 2. Here, H2n plus 1 OH we can write. That is the general formula of alcohol. Now, let us see. Alcohol's general formula we can write Cn H2n plus 1 OH. Each member we can write. The molecular formula as we have seen now, CH3OH is the first member. Its name is methanol. Next C2H5OH, ethanol. C3H7OH, propanol. C4H9OH, butanol. C5H11OH, pentanol. C3H13OH, hexanol, etc. In this series also we can see what is the difference between the first member and second member? One carbon and two hydrogen atoms. That means they differ by a CH2 group, or the mass we consider, we can say they differ by a 14 unit of mass. Same thing between the second and third also. Second and third member, ethanol and propanol also we can see they differ by a CH2 group and or differ by a 14 unit of mass. And all these having same functional group. Which is the functional group here? OH. You have learnt already the organic compounds which have a functional group. The chemical behavior of the compound is determined by the functional group, not by the carbon and hydrogen. So as same functional group, all these members are having same functional group OH. All these show similar chemical properties. And as the molecular mass is increasing, they show a regular variation or regular gradation in their physical properties like melting point, boiling point, all these. So here also we have seen just like alkanes, the successive members or adjacent member differ by a CH2 group. All these can be represented by the same general formula. All these are having the same functional group. They have the same chemical properties and regular gradation they will show in their physical properties. Same thing for alkenes also. Alkenes, as we have seen in the previous class, we know how to write the molecular formula. General formula is CnH2n. So molecular formula first member. There is no alkane with one carbon because there should be at least two. Between two carbon atom, there should be at least one double bond. So at least two carbon atoms. So first member is ethene, C2H4. Next one, C3H6 propene. Next, C4H8 butene, C5H10 pentene, C6H12 hexene. So here also you can see each member differ by a CH2 group. So each successive members differ by a CH2 group or 14 mass units. And they all are having same chemical properties. They show a regular gradation in their physical properties. All these can be represented by the same general formula CnH2n. So all these type of series of organic compounds, they are called homologous series. So we can say alkenes is a homologous series. All these members of alkenes show similar chemical properties. Adjacent member differ by CH2 group. They have regular gradation in physical properties. All these can be represented by a same general formula. Same for alkynes also. General formula CnH2n minus 2. So we can write first member C2H2 ethyne, then C3H4 propyne, C4H6 butane, C5H8 pentyne, C6H10 hexyne. Here also all these members can be represented by the same general formula. They show similar chemical properties, regular gradation in their physical properties, and uh, so all these are also we can consider as a homologous series. Now let us see, considering all these points, let us see the definition of a homologous series. A group of organic compounds which can be represented by the same general formula have the same functional group, similar chemical properties, and the successive members of the series differ by a CH2 group and 14 mass units is called a homologous series. Once again, a group of organic compounds which can be represented by the same general formula have the same functional group, similar chemical properties, and the successive members of the series differ by a CH2 group and 14 mass units is called a homologous series. Now can you give some examples for homologous series? You can take the example of alkanes. Some 3-4 members you can write, and you can apply all these property in that we can show successive member differ by CH2 group. All these can be represented by the same general formula CnH2n plus 2, etc. All this you can apply there and you can explain if the example is asked. Or you can take the example of alcohol, some 3-4 alcohols, molecular formula you can write. You can apply all these and you can prove that these are alcohols from the homologous series. So if example is asked. Now let us see what are the characteristics of a homologous series. We have seen already in the definition, same thing, only point wise you have to write for the characteristics. So let us see, all the members of a homologous series can be represented by the same general formula. Next, successive members differ from each other by a CH2 group. Successive member means adjacent members, the nearby members. Next, physical properties show irregular gradation. Next, they have similar chemical properties. Next one, they have same functional group. So next we are going to discuss a few questions which is given in your textbook. Let us see the first question. What would be the electron dot structure of carbon dioxide which has the formula CO2? So to write the electron dot structure, we have seen already when discussing the covalent bond, we have written a few electron dot structures of hydrogen, nitrogen molecule, CH4, etc. Similar way we can write for carbon dioxide also. Here one carbon and 2 oxygen atoms. So what is the atomic number of carbon? 6. Its electronic configuration is 2,4. That means in the carbon, in the outermost shell there are 4 electrons. Oxygen atomic number is 8. So electronic configuration is 2,6. Oxygen is having 6 electrons in the outermost shell. So always when you are drawing the electron dot structure, we are considering only the outermost shell electron. So oxygen, as it is having 6 electrons in the outermost shell, it requires 2 more electrons to complete the octet. How many electrons carbon require? It requires 4 electrons to complete the octet. So let us see how it share the electrons. So here you can see carbons having 4 valence electron. It needs 4 more electron. So it shares with the 2 electron of this oxygen and 2 electron of this oxygen. So you can see now carbon is having 8 electron. Oxygen's outermost shell there are 6 electrons. So it needs 2 more electron. So it share with 2 electron with this carbon. Another oxygen, because in carbon dioxide there are 2 oxygen molecules, oxygen atoms. So this oxygen also need 2 more electron. It share the 2 electron with this carbon, and so how many pairs of electrons are shared between this carbon and oxygen? 2 pairs. So here is a double bond between carbon and oxygen. Here also 2 pairs are shared. So a double bond between carbon and oxygen. Now you can see carbon also getting 8 electrons. Each oxygen also having 8 electrons. So this is the electron dot structure of carbon dioxide. Next, what would be the electron dot structure of a molecule of sulfur, which is made up of 8 atoms of sulfur? So one hint is given here. The 8 atoms of sulfur are joined together in the form of a ring. So in the question already it was given, one molecule of sulfur means there are 8 atoms. Its formula is S8, sulfur molecules formula. So these are joined together in the form of a ring also it is given. You know sulfur atomic number, it is 16. So how to write the electronic configuration? 286. How many electrons are there in the outermost shell? 6 electrons. So it requires how many more electrons? 2 electrons. So let us see how it shared. So here as it is given, they are joined in the form of a ring. You can draw one ring with 6 circles around the sulfur. 6 sulfur atoms, overlapping rings you can draw. Then each sulfur is having 6 electron and it needs 2 more electron. So how it get 2 more electron? This sulfur shares with 1 electron of this sulfur. Again it shares with 1 electron of this sulfur. So you can see here for this sulfur there are 8 electrons. Same way this sulfur also shares with 1 electron of this sulfur and 1 electron of this sulfur. So each sulfur shares 1 electron each with the adjacent 2 sulfur atoms and forming a ring structure. So each sulfur single bonds are formed here. So for this question how we can write the answer? You can draw 8 overlapping circles around the sulfur, and one pair of electron is shared between each sulfur atoms remaining. So here 2 uh, for this sulfur here 1 electron, here 1 electron. So remaining how many electrons are there? 4 electrons, because sulfur is having 6 valence electron. Those 4 electron you can show here. This is the electron dot structure of sulfur. Next, what will be the formula and electron dot structure of cyclopentane? So, like this question is asked, molecular formula we can decide because we know the general formula of cycloalkanes. It is cyclopentane is a cycloalkane. General formula is cycloalkane. It is CnH2n, which is similar to the alkenes formula. We have learnt already. So, cyclopentane molecular formula, what it will be? Pentane means there will be 5 carbon atoms. So the molecular formula is C5H10 when we are applying the general formula CnH2n. Now how to draw its electron dot structure? Like this, any organic compound or carbon compound electron dot structure is asked. To draw the electron dot structure, it will be easy if you are drawing first the structure with the bonds. You know how to draw the structure of cyclohexane. Cyclopentane. This is not cyclohexane, children. Cyclopentane it is. Formula of cyclopentane. So we have drawn the structure of cyclopentane. Cyclopentane molecular formula is C5H10. We have drawn its structure with a pentagon with 5 carbon atoms in each corner and 2 hydrogen. Already we have learned how to draw the structure. So if you are drawing the structure with the bonds, it will be easy to draw the electron dot structure. This is not the electron dot structure. Now we are going to draw the electron dot structure. So how to draw the electron dot structure for this? You can draw circles around this carbon. Around each carbon you can draw overlapping circles. The circle overlap with the circle overlap with the circle, such a way. And each carbon you can see it is bonded to 2 hydrogens each. So for this carbon circle you can draw 2 hydrogen circle. Here one hydrogen, here one hydrogen you can draw. Then each one you can draw in such a way. Then you can see the bond between the two atoms. So here between these two carbon atoms there is single bond. Single bond means how many pairs are shared? One pair of electrons are shared. So you can see here the common space between these carbon atoms. Between the circles you can show one pair of electron. Here also single bond, one pair you can show. Here also one pair you can show, and so on. Let us see. So seeing this, you will find it difficult how to draw the structure. So once you draw the structure with the bonds, then you can draw the electron dot structure. It is very easy. So what you have to do? Around each carbon, draw circles. Overlapping circles. Around this carbon, one circle. Around this carbon, one circle. Then around each hydrogen also one circle. So for this carbon, there are 2 hydrogen atoms. We have drawn overlapping circle. For this carbon, there are 2 hydrogen atom. For this carbon, 2 hydrogen atom. Overlapping circles we have drawn. For this carbon, 2 hydrogen atom, and so on. For all these carbon atom, 2 hydrogen we have drawn. Next, what we have to see? We have to see what bond is present between two atoms. Between these two carbon, one single bond is formed. That means one pair of electron is shared here. Between these two carbon also, one pair is shared. You can show 2 electrons. Between these two carbon also, one pair is shared. These two carbon also, one pair. These two carbon also, one pair. So the common space between the two circles, you can mark 2 electrons. So electron either with a cross mark or with the dot mark we can represent. So here to differentiate between the hydrogens, electrons of hydrogen and electron of carbon, carbon's electron is represented by the cross mark and hydrogen electron by the dot mark. So here you can see between these carbon and hydrogen there is a single bond. Single bond means one pair of electron is shared. So to differentiate the carbon's electron and hydrogen's electron, we have taken here cross for carbon and dot for hydrogen. So 2 electrons we have shown here. For each carbon hydrogen bond we have 2 electrons we have shown here. So if you want, you can give for dot for carbon and cross for hydrogen also. So once again, how to draw the electron dot structure? To draw the electron dot structure, first you draw the structure with the bonds. After that, you draw the circles around the atoms, or overlapping circles around the atoms. Whichever atom is present, whichever bonding is taken place, accordingly you can draw the circles. Then you see which bond is present between the atoms. So single bond is present, you can show the common space between the circles, one pair of electron. If it is double bond, suppose any double bond is present here, how many electrons you have to show in the space, common space? You have to show 4 electrons. Hope it is clear. So this is the electron dot structure of cyclopentane. So directly, instead of drawing directly the electron dot structure, if you are drawing the structure, then you draw the electron dot structure, it is easy. Next, draw the electron dot structure for ethanoic acid. So to draw the electron dot structure for ethanoic acid, first we have to draw the structure of ethanoic acid. How to draw the structure of ethanoic acid? Ethanoic acid means there are 2 carbon atom and oic acid represent one carboxylic group is present there. C double bond O single bond OH. Other carbon atom we can satisfy the valencies with the hydrogen. Already we have seen how to draw this electron dot structure. 2 carbon atom, in that one you can make it as a carboxyl group. The functional group is carboxylic acid group here, oic acid, other with the hydrogen. So how to draw the electron dot structure here? Around each carbon draw the circle. For oxygen also draw one circle, hydrogen also draw one circle. Here this oxygen also draw one circle, this hydrogen also, this hydrogen, around this hydrogen draw the circles. Now you can see how many electrons are shared here? One pair, because one single bond is present here. That hydrogen you can represent with a dot and carbon with a cross, means in the common space you can draw 2 electron, you can show one dot and one cross. Here also same, here also same. Here carbon we are representing with a cross, so each carbon two electrons, so one pair is shared here. So both you can show with the cross. Here how many pairs are shared? 4 electrons are shared because double bond is present here. So carbon's 2 electron, cross mark 2 cross mark, and oxygen you can give dot mark 2 dot you can give. Here one pair is shared, you can one cross and one dot you can give. Here oxygen and hydrogen both we are given dot, so 2 dots you can give. Okay. So now oxygen, the common space, if you are giving 2 bonds, you are showing with 4 electrons. Now you know oxygen valence electrons are 6. So in this 2 are taking part in the reaction here. How many are remaining? 4 are remaining. That you can have to show extra oxygens here, extra electrons here. So let us see, around this carbon you have drawn one circle. This carbon you have drawn one circle. Oxygen we have drawn one circle. Around this hydrogen we have drawn one circle. This oxygen also one circle. This each hydrogen also one circle we have drawn. As it is double bond here, single bond here, 2 electrons you can show, one pair, one electron, hydrogen one dot and carbon cross you can draw. Here also same thing, here also same thing. And here you can see one single bond, so you can 2 cross mark you can give. That means 2 electron, one pair is shared. Here also uh, between this carbon and oxygen one pair is shared. One carbon electron and one oxygen electron you can show one cross and one dot. Here you can see oxygen and hydrogen one electron is shared. So oxygen's one electron and hydrogen one electron you can show. Here 2 pairs are shared. 2 electron of carbon with the cross mark and 2 electron of oxygen with the dot mark. Now you know valence electron number of oxygen is 6. So in this 2 electrons are shared with this carbon. How many electrons are remaining? 4 electrons. That around this oxygen anywhere you can show these 4 electrons. Same for here also. Here 1 electron of this oxygen and 1 electron is oxygen. They are sharing with this hydrogen and carbon respectively. So remaining 4 electrons you can show anywhere. So once again, if the electron dot structure is asked, first what you have to do? This is not the electron dot structure, this is structure. So to draw the electron dot structure easily, first if you are drawing this structure, it will be easy for you to draw the electron dot structure. So first you draw the structure with the bonds. Then around each atom you draw the circles. Then after that you have to see how many bonds are present. If it is single bond, the space which is common for both the circles, you give 2 electrons. You show 2 electrons. Single bond means. So it is different atoms you are representing with a different cross and dot, means accordingly you have to give this. So if it is double bond, how many electrons you have to show? You have to show 4 electrons. That means 2 pairs are shared, only double bond is formed. So this is the way. So around each atom draw the circles. The common space you see the bond and decide how many electrons you have to draw. So single bond means 2 electrons you have to draw. Double bond means 4 electrons you have to draw. Now this carbon, all the 4 electrons are taken part in the reaction. So there is no extra electron. Hydrogen, only 1 electron that is taking part in the bonding. So there is no extra electron. That's the reason we are not representing like this oxygen. We are not representing other electrons here. Oxygen, here 2 electrons only take a part in bonding. Remaining 4 electrons also we have to show here. Same thing for here also. Hope it is clear. Next, H2S. You know sulfur's atomic number is 16. Its outermost shell there are 6 electrons. And hydrogen is having 1 electron. So each hydrogen need 1 more electron. Sulfur require 2 more electrons. So how they are sharing? Let us see. Sulfur, it is having 6 electrons. So 1 electron of this sulfur and 1 electron of this hydrogen. So here 1 electron of this sulfur and 1 electron of this hydrogen, they are mutually sharing. Here also 1 electron of the sulfur and 1 electron of this hydrogen also mutually shares. So one single bond is formed between the sulfur and hydrogen here. Here also one single bond. Now you can see sulfur is getting 8 electrons. Each hydrogen gets 2 electrons each. Next, let us see propanol. So, how to draw the electron dot structure of propanol? For this, if we are drawing first the structure of propanol, it is easy to draw the electron dot structure. So, how to draw the structure of propanol? As it is propanol, the name indicate it is having 3 carbon atom and ONE that indicate it is having a ketone functional group. So, you know, ketone functional group should be always in the middle. So, this is a structure of propanol. How to draw it? Already we have learned. So, how to draw its electron dot structure now? We have to draw circles around each atom, each carbon, each hydrogen and oxygen. We have to draw circles. And here one single bond is present. So, here you have to draw, show 2 electrons. That means one pair. Here also you have to show 2 electrons. Here also 2 electron. Here also 2, 2, 2, 2, 2. Here there is a double bond. So, you have to show 4 electrons. That means 2 pairs. Let us see. So, draw one circle around this, one circle around this carbon, one circle around this carbon, and around each hydrogen, draw one circle each. For this hydrogen, one circle, this hydrogen, one circle for this hydrogen, and one circle for this hydrogen, and one circle for this oxygen. Now, look at the bond. Here it is. So, first you can draw the structure. After that, next step you can draw the circles. Next, you have to represent the electrons. So, how we can represent electron? Here's a double bond, sorry, single bond. So, one pair of electron is shared. That means 2 electrons. You can show here 2 electrons. Here also one single bond, 2 electrons. Same way here also 2 electrons. Here 2 electrons. Here 2 electrons. Here also 2 electrons. Between these 2 carbon also one single bond, you can show 2 electrons. These 2 carbon also you can show 2 electrons. Between these 2 carbon and oxygen there is a double bond. So you have to show 4 electron. Cross for carbon and dot for oxygen. And oxygen is having 6 valence electrons. So 2 electrons are shared here with this carbon. Remaining 2 electrons anywhere around this oxygen you can show 4 more electrons. So, to draw the electron dot structure of any organic compound or carbon compound, first what you have to do? You have to draw the structure, then it will be easy to draw the electron dot structure. Now, each atom you draw one circle. Then you see which bond is present between the 2 atoms. So, if it is single bond, you have to show 2 electrons. If it is double bond, you have to show 4 electrons. This is the method. So, first itself you are seeing this, it will be totally confused for you. So, first you draw the structure, then you draw the circle, then which bond is present, according to that the number of electrons you show here. So, easily you can draw the electron dot structure of any compound it is asked. Any compound can be asked like this. Next, let us see F2, fluorine molecule. You know fluorine's atomic number is 9. So, its electronic configuration is 2, 7. So, there are 7 electrons in the outermost shell. So, each fluorine requires one more electron. So, it shares one pair of electron between these 2 fluorine. One electron of this fluorine and one electron of this fluorine, they are mutually sharing. A single bond is formed between these 2 fluorines. Next, this already we have discussed in the previous class. Once again, we'll see how to draw the structures of the following compounds. Ethanoic acid. Ethanoic, from the name we'll get there are 2 electrons and 2 carbon atoms. One carbon atom, you have to make it as the functional group COOH as it is oic acid. Remaining valency you have to satisfy with the hydrogen. So, this is the structure of ethanoic acid. C bonded to 3 hydrogen. Another C, double bond or single bond OH. This is the carboxylic acid functional group. Bromopentane. So, pentane means 5 carbon atoms and bromo is a functional group. One carbon is attached to functional group Br. Remaining valencies with hydrogen. Next, butanol. How many carbon atoms? 4. And ONE means 1. One you make it as CO group. Don't make the end carbon as a CO group because ONE ketone always will be present in between 2 carbon atoms. Either this you can make CO or this you can make CO, anything. Remaining with the hydrogen. Hexanal. Hexa means 6 carbon atom. Al means the functional group is aldehyde CHO. So, any one end of the carbon atom, you make it as CHO, C double bond or single bond H remaining with the hydrogen. Next, are structural isomers possible for bromopentane? You have seen already how to draw the structure of bromopentane. Now here the bromine is attached to this carbon, one end carbon. Same way bromine can be attached to this carbon also, this also. So accordingly we are getting different isomers, different structures. So how to name this carbon compound? We are giving where the functional group is attached to that carbon, we are giving the least number. Such a we are numbering. So here we have to start numbering from this carbon. 1, 2, 3, 4, 5. So this is called 1 bromopentane, one isomer. If you are drawing the bromine here, that is 2 bromopentane. And bromine here for this carbon, if it is attached, this is 3 bromopentane. So structural isomers are possible for bromopentane. We are getting 3 structural isomers. 1 bromopentane, 2 bromopentane, 3 bromopentane. Now you will have a doubt. We can draw here also, that will become 4 bromopentane and here means 5 bromopentane. No. If we are drawing here, I have told you already to name these such type of compounds which have a functional group. We have to number in such a way. We have to start from one end such a way that carbon which is attached to the functional group should have least number. So if here we are attaching the bromine means numbering we have to start from here. 1, 2. From here you are starting means the number is 4. From here we start means number is 2. So the functional group should get the carbon with the functional group should get a minimum number, least number. So this, if you are drawing here the bromine, this 2 bromopentane and this is same. If you are drawing here the bromine, where we have to start the numbering for this carbon, that is 1 bromopentane. So both are same. So here there are 3 isomers possible for bromopentane, 1 bromopentane, 2 bromopentane and 3 bromopentane. While drawing the structure, no need of giving these numbers. To understand how the numbering is given, I have given these numbers. Okay. So now next question. Ethane with molecular formula C2H6 has how many covalent bonds? This is one example question. So like this any compound can be asked. So to find out how many covalent bonds are present, what you have to do? You have to draw its structure. If you draw its structure, then you count how many numbers of covalent bonds. 1, 2, 3, 4, 5, 6, 7. If you are drawing any ketone or aldehyde there or alkene, alkyne, the triple bond will be there. That also triple bond means 3 bonds you have to count it as. Any double bond is there, you have to count it as 2 bonds like that. Next. So the answer is 7 covalent bonds. Next question. Butanone is a 4 carbon compound with a functional group. So butanone, what is the functional group? ONE. It represents a ketone. So the functional group is ketone here. So similar question can be asked. Propanol is a 3 carbon compound with a functional group. Propanol, Al, it means which is a functional group? Aldehyde. Next, one question can be asked. Ethanol is a carbon compound with a functional group. Ethanol, oil means which is a functional group? Alcohol. And butanoic acid, which is a functional group? Carboxylic acid. Like that different question can be asked. So today we have discussed what is a homologous series and examples for homologous series we have seen and what are the characteristics of homologous series, and we discussed a few textbook questions. Hope you understood today's class. Thank you children.